Today our topic is Bronsted Lowry theory of acids and bases. Okay, this theory was given by Bronsted, a Danish chemist. This theory was given by Bronsted, a Danish chemist, and Lowry, an English chemist. Independently in 1923. Independently in 1923. According to this theory, according to this theory, an acid is a substance. An acid is a substance, molecule or ion which has tendency to release the proton. Okay, here proton is H plus ion. This proton released substances we are calling protogenic. These are called protogenic. Okay, and similarly a base has tendency to accept proton, These are called photophilic. Protogenic means proton generator, photophilic means proton acceptor. For example, HCl and water, to form H3O plus and Cl minus, in the above reaction, that means this reaction, HCl here proton donor, H plus donor, it becomes Cl minus. How it is? HCl become Cl minus. It's proton donated to water. This water become H3O plus. Then this HCl act as acid. This is proton donor, and here water accept that proton to become H3O plus. This is called Bronsted-Lowry base. The reaction, HCl act as acid, proton donor, and water molecule accept the proton to become base. Based on these examples, we can also say this Bronsted-Lowry theory, proton donor and acceptor theory. This theory also called proton donor and acceptor theory. Proton donor and acceptor theory. Simply we can say this. What is this acid and proton donor is Bronsted-Lowry acid, proton acceptor is Bronsted-Lowry base. Few other examples we will see. Okay, few other examples. For a suppose here we are taking acetic acid CH3COOH and water to become H3O plus and CH3COO minus. Okay, in this one, this is acid to donating proton to become CH3COO minus. Okay, that proton is accepted by water. Okay, then it become a base. Okay, another example. Ammonium ion plus water. Ammonium ion plus water. It become H3O plus and ammonia NH3. Here ammonium ion donating proton to become ammonia. Okay, this is act as acid, and here water also, water become H3O plus, water accepting H plus ion to become H3O plus. This is act as base. Okay, one more example. Suppose we are taking ammonia in water. Okay, it becomes NH4 plus and OH minus, NH4 plus and OH minus. Here you can see what is here, NH4 plus is forming, NH3 become NH4 plus. Okay, it is accepting proton, then it is act as base, and water here releasing proton, okay, to become OH minus, then it is acid. Okay, what we are observing here in example 1 and 2, okay, here 1 and 2, water act as a base, okay, and in example 3, water act as acid. Okay, from this we can say water can donate as well as accept proton, as well as accept proton, okay, and can act as both acid and base, both acid and base. Okay, here we can say few examples like okay, species like H2O, NH3 and CH3COOH, okay, which can act as both acid and base, are called amphiprotic. Okay, here already we discussed protogenic, protophilic, and this is amphiprotic. Protogenic means proton generator, proton releasing substance. Protophilic means proton accepting substance, and here which can act as both acceptor as well as donor. Okay, donor and acceptor. This one we are calling as amphiprotic. See, here two more important points are there here. According to this theory, an acid losing proton to become a base, an acid on losing a proton to become a base is called conjugate base. Is called conjugate base. While the base accepting proton okay, to become an acid is called conjugate acid. Conjugate acid. See, here I am writing clearly. Observe properly. Here I am writing acid. Acid means which give proton and become a base. That base we are calling as conjugate base. Conjugate base. Similarly, here base which can accept proton to become conjugate acid. To become conjugate acid. With the help of example, we will see. Suppose HCl is an acid. Okay, it produces H plus ion and Cl minus. Okay, here Cl minus is the conjugate base of HCl. Conjugate base of HCl. Okay. Similarly, for bases we can see. Suppose base NH3 is a base which can accept proton to become NH4 plus. NH4 plus. Here NH4 plus is the conjugate acid of NH3. Conjugate acid of NH4 plus is conjugate acid of NH3. Okay. See, two more points we can. What is that? When strong acids, okay, conjugate base of strong acid is weak base. Conjugate base of strong acid is weak base. Weak base, and vice versa for acids. Okay. Next, conjugate acid of strong base. Conjugate acid of strong base is weak acid. Okay, and vice versa. Okay, here we can see one example for strong acid, strong base. For example, strong acid is HCl is a strong acid. Okay, it produces proton and becomes Cl minus. This is strong acid releasing proton and become weak conjugate base. Weak conjugate base. Okay, one more example for weak acid. CH3COOH, okay, donating proton and become a CH3COO minus. Here this is weak acid releasing proton. It becomes strong conjugate base. Strong conjugate base. Here these 4 points are important. Here the acid which can releasing proton, okay, and become a conjugate base, and here the base accepting proton to become conjugate acid. Here strong acids gives weak conjugate base, weak acids give strong conjugate base. Okay, vice versa. Okay, this is Bronsted Lowry acid base theory. Okay, thank you. We will see next video with help of examples.